Today we're looking at the first part of Section 11-3 in our geometry book, covering surface area of pyramids and cones. This part 1 will cover pyramids. So let's go through what some definitions are that we have in the book. The first is a pyramid is a polyhedron in which one face, the base, can be any polygon, and the other faces, the lateral faces, are triangles that meet at a common vertex. And I've got a pyramid drawn in here to the right. In this case, the base is a hexagon, and you can see that each of the lateral faces is a triangle, and they meet at the top at a common vertex. The altitude is a perpendicular segment from the vertex to the plane of the base, and it's going to hit in the center of the base, and we're going to call the length of that altitude the height h. A regular pyramid has a base that's a regular polygon, and the lateral faces are congruent isosceles triangles. So that's something to keep in mind, and unless it's stated otherwise, we should assume that the pyramids are all regular. The last part of this is the slant height L. I have another pyramid drawn down at the bottom right, and I have the height marked in blue, but the slant height L is the height of or the altitude of a lateral face. So if I was looking at the triangle that's one of the lateral faces, and if I drew the altitude in for that, then that would be called the slant height L. Okay, so to the right here I've drawn a pyramid and opened it up. So I've taken that vertex and I've pulled the lateral faces down so that we can look at it. The lateral area of a pyramid is the sum of the areas of the congruent lateral faces. So the lateral area does not include the base. It's only in this case, the 4 triangles that are congruent. So if I were looking at this, the side of the base, each side is S, this is a square. The lateral height is drawn in, the lateral slant height is drawn in there, and so if I were going to find the area of one of these triangles, it would be 1/2 the base, which is S, times the height L. Well, they're all the same. These are all congruent triangles. So in this case, I would be multiplying 4 times the 1/2 side times slant height L. Okay, this is a special case, but in general, we could, and then if we think of this as, let's just spread the 1/2 out front for now. But if I did 4 times S, and then times the lateral height, the 4S would be the perimeter of the base. Okay, so we could think of this as 1/2 times the perimeter times the slant height. So that's what I'm going to write for my formula. I'm just going to write 1/2 times the perimeter times L. Now the P is the perimeter of the base, not the triangles. Okay. Now, in order to find the surface area, it's like we did in the last section. If I'm finding the surface area, I'd add the lateral area plus the area of the base. This time, for the pyramid and the cone, we'll see there's just one base. So in the other section, we had 2 bases, and we had 2 times the base here instead of just the area of one base. But since I only have one base this time, then that's all I'll be adding. So if I was going to write it using the 1/2 PL, I would write that would be 1/2 perimeter times the slant height plus the area of the base, whatever that happens to be. I'm just going to call it capital B. So that means the area of the base. Okay, example 1 has a hexagonal pyramid drawn in, and we're going to try to find the surface area of that. So I attempted to draw the hexagonal pyramid here, but I just brought the base out to look at to the above it so that we could see it clearly. So remember, the surface area is just going to be the lateral area plus the area of the base. The lateral area we said was 1/2 times the perimeter times the slant height. And then the area of the base, it depends on what the base is. So this time we have a hexagon. It's a regular hexagon because this is a regular pyramid. All right, we're given the apothem, and we're given the side. So remember that the area of the base, this was back what we did a few chapters ago, will be 1/2 the apothem times the perimeter. So that's going to be 1/2 times 3 squared of 3 times the perimeter, which is the 6-inch side times how many sides there are. So 6 times 6 is 36. Oops. I'm moving my line. All right. So if I'm using my calculator and I multiply that out, that's going to end up giving me 93.0307. All right, so now I just need to figure out 1/2 times the perimeter of the base times the slant height. Now we already know the perimeter of the base was, we said 36, so this will be 1/2 times 36 times the slant height, which was given as 9 inches. All right, so if I put all of this into a calculator, the 1/2 36 times 9 will end up being 162. Plus the 93.0307. That's going to end up giving me 255.53, or if I was going to round it to the nearest one, it would be about 256 square inches. Now pause and try the quick check one, which is to find the surface area of a square pyramid with base edges 5 meters and slant height 3 meters. This time the figure's not drawn, and you can draw it in if you want, or you can just do it using the information you're given. Okay, hopefully you tried that out by yourself. So I've got surface area equals 1/2 the perimeter times the slant height, plus the area of the base, which in this case is going to be side squared because it's a square. So the base edges are 5 meters. That's my S. The slant height is 3 meters. That's my L. So the perimeter, if we have a square, would be 5 times the number of sides, which is 4, or just 20. All right, and we know that L is the 3 meters. All right, so we should be able to plug everything in now. So I have 1/2 times 20 times 3 for the slant height, plus the side squared, so 5 squared. That's going to give me 30 plus 25, which will be just 55. And this time the units are inches squared. All right, I have another video coming out that has the lateral area and surface area of cones. So watch that and try your homework.